Dr. Ardigmajan here with Prime Coral, and I have a adult Philaster parasite. This is the RTN Parasite, and this is Philaster lucinda. He has a little bit of stage fright. So I took this parasite out of a culture of a coral that RTN, and this is a mature adult. Its length is about 200 microns, and we're going to take a look at some still shots in a minute, but I wanted to let you see what they look like when they're swimming around slowly. Their bodies are about 200 microns in length and about 20 to 25 microns in wide. The surface of the body is covered in cilia. Cilia are tiny hair-like projections, and it allows them to basically move through the coral and move through the water. So just to get you familiar with the anatomy of a Philaster, again, there's two types of Philaster. They're Philaster lucinda and Philaster guamense that affect coral. They infect the coral and they cause the coral to become sick. They multiply within their host under the skin of the coral, within the skeleton, and eventually their numbers become into the thousands and they overwhelm the host and kill it. The coral dies either as RTN in the case of Philaster or STN in the case of Philaster's cousins like the Stera or Euploides or Cryptocaryon. Some of the things to note: this is the head of the Philaster. It has a long neck, and it's able to move that neck by twisting it side to side. Typically when the Philasters move through the water, they rotate along their long axis, so they kind of spin around, like a little spinning torpedo as they move. They're able to redirect their bodies to go right, left, up, and down by twisting this neck region. Remember, this whole thing is one cell. This is not a multicellular organism. The mouth of the Philaster is located here. They basically consume coral tissue and zooxanthella. This here is a vacuole, which is a cytoplasmic organelle that stores things. You can see here are zooxanthella that is eaten, and here are zooxanthella moving towards where it excretes waste through another vacuole at the back end. And these zooxanthella are in the process of being broken down. They're digesting, and you can see they're turning a reddish color. I believe this parasite, which came out of an acropora that died about 2 days ago, I believe it's starting to digest the zooxanthella that it had stored within its body. So these parasites will actually consume about anywhere between 30 to 80 zooxanthella. They'll store them in their body, so when there's lots of food around, a nice healthy coral they're eating, they're going to store a lot of those zooxanthella and probably even use the sugars produced by the zooxanthella as energy. But when there's no coral around to eat, they start to digest the zooxanthella. And that's what we're seeing happening here. Earlier I saw a little piece come out its butt. I assume that's a digested little vacuole of zooxanthella. The other thing I want to point out about this little parasite is the color in its cytoplasm. Very important. Have you ever noticed a green skeleton after it's RTN? We have plenty of them. Just about every single acropora that's RTN that I've ever seen, or other type of coral, goniopora, they have a green tint to their skeleton. I believe that green tint comes from these green particles inside the parasite. For some reason, it's got a green pigment to it. And you can see the older it gets, the bigger they get, the more green. The younger ones don't have this green pigment or dye. So that when I see an acropora that's dying, it usually starts dying at the base, and the base will have a very green pigment to it. At first, when I first started seeing corals dying in my system, I thought that green pigment was copper or iron, and that I was dosing my system with too much copper and iron. But I tested my copper and iron levels, and they were fine. So somebody once told me it's algae, but the problem is, as soon as the coral dies, it's already there, unless algae is growing under the coral skin, which I don't think is happening. So basically the source of the green color on the coral skeleton that's RTN is actually coming from the green pigment within this philaster. And it's been documented in my research. I found that these organisms, many of the older ones that have been around for millions of years, they have a green or brown pigment that they secrete. So what I think is happening is the first generation of these that's pioneering or invading the coral, once they reproduce and die, they basically release this green pigment into the coral skeleton, staining it. So when you look at a coral skeleton that's dying and you see an area that's stained green, that's probably the first area that was infected in the coral, where the original invaders of the coral probably set up shop and died and released a lot of their green toxin. Meanwhile, giving birth to thousands and thousands of babies that ended up somehow killing the coral through a process that I'm not 100% sure how it happens. I just know that it happens. So once again, you see the neck, you see the body, you see the bottom area where it excretes. You see the zooxanthella, it's only got about maybe 10 left inside. So it's running low on energy reserves. Here's another picture. Again, the mouth is pretty big. It's pretty much the whole front. And then the tail area and the body is covered in cilia. That's how it moves so fast. A little better view of the contents within the cytoplasm. The head is out of focus, but you can see the bottom here, and you can see all the zooxanthella that are still being digested. It looks like the digestion of the zooxanthella occurs as they move towards the back of the parasite. And if I had to guess, I would say these vacuoles or cytoplasmic clear basically sacs are probably digestive sacs. They probably either fuse with the zooxanthella or somehow they connect or engulf the zooxanthella and cause it to be digested. Here's another picture of the philaster. Again, these are the RTN parasites that cause coral RTN or brown jelly, rapid tissue necrosis. And in my research, these are what I have shown consistently killing corals, and it doesn't matter what kind of coral, they kill all coral, and every dying coral with RTN, brown jelly, has this parasite in it.